Alright, so in this video we'll be taking a look at the FTC TETRIX competition set kit, and we'll be looking at just what it comes with and what we'll need to create a robot. So I have the kit here. It comes in this nice blue container. So I'll take off the lid and we'll take a look at what it comes with. So the first thing you'll notice is that this little sheet that's on the top, it has a list of everything that's in the kit. So if you ever need a reference for like what a certain piece is called, or like the part number or anything like that, you can go here and look at it, and they're organized by category. So like we have bars and angles, channels, plates and brackets, nuts and screws and fasteners. And so you can go ahead and just look at those, and it'll tell you not only what it is, but how much of each, the quantity of each. And so that's pretty handy. It lets you know the names of something if you don't know a certain name. And then up here at the top we can see how many pieces it has. So there's 824 pieces. It's a lot. So yeah, so this is just what the top sheet is. So make sure you keep this. And I've already gone ahead and opened up everything. So when you get this, it'll all be sealed and wrapped in bags. So you want to go ahead and open up everything and start to organize all your stuff. So this top tray, I've gone ahead and put all of my pieces in here. So the kind of stuff I put in here is just like small little things that can get lost if they're somewhere else. So like I have my 832 screws, the two 832 screws up here, my 832 nuts, we have my motor mounts, my axle mounts, and we have like the bushings here, the brass bushings, my standoffs. These are 832 standoffs as well. Our motor mounts and our various axles, two different sizes. Yeah, and so that's pretty much what it comes with. There's also some lock nuts, or sorry, lock collars. And then up here at the top I've put the tools, because it does come with tools, so you don't have to source those out yourself. So for example, we have a screwdriver, and so with this screwdriver it's a 2-in-1. So on one side it's a Phillips head screwdriver, and then if you take this piece out and flip it around, it's also a flathead screwdriver, which is pretty neat. We have our other screwdriver, we have our Allen wrenches. There's this, like, I believe 4 for the different sizes, and then we also have these for I believe these are for the nuts, to unscrew the nuts a little bit easier. Yep, so these are for the nuts. And yeah, so that's what I put on the top of my tray. You don't have to organize it exactly like this, but I just felt like if I put like the small stuff together, and I've kind of grouped things in an orderly fashion. But yeah, go ahead and put your smallest stuff on the trays, and then on the bottom I've taken out all the big stuff from the bags and put it there. So we'll start out with the aluminum pieces. So all of these are our plates, brackets, C-channel, you name it. All the metal pieces I put here at the bottom. So there's a lot of C-channel with the kit. So all of this is just C-channel and plates. And they also come with some smaller metal pieces, and so I put just these in a box just so they don't kind of get lost, because they are a little smaller than the C-channel and plate pieces. So I put them in a box. These are just like brackets and connector pieces. That's all that's in here. So if you want to put those separate, you can as well. And so apart from the metal, we also have a bunch of other stuff. So here are our electronic pieces, our gears, and our wheels. So first look at the gears. Fortunately, these do have gears of different sizes, which is good, and they're out of metal as well. So we can create our own gear reductions, or make our speed faster, increase our torque, the whole 9 yards with the gears. they're all different sizes as well. We have various ones, and I put those in a Ziploc bag. And then we also have our wheels. So we have the regular wheels, and there's 4 of them. And then we also have Mecanum wheels. Sorry, Omni wheels. We have 4 Omni wheels. And so they're all 4 inches in diameter as well, for reference. But if you don't know already, the difference between the regular wheels and the Omni wheels is that the Omni wheels are omnidirectional wheels, as it implies in the name, can move in all directions. So what that means is that it can basically move left and right and front and center. So with these wheels, you can pretty much only move front and back. So you can only go forward or backwards. And you can't really go to the side because of the rubber on the wheels. It creates friction with the ground, so you can't move sideways. So what these have, they have rollers on them, right? And so these rollers minimize the friction between the wheel and the ground. So that way it can slide across like that. And even on my hand, it's able to slide across, whereas there's more friction, so you can't really do that. So that's what the Omni wheels are used for. So in total you have 8 wheels. So you can do a lot with those. You can even create like flywheels as well as having wheels for your drivetrain. So I put the cables in just a rubber band. These are like the servo cables and the cables for the DC motor. And any like analog input you have, any analog input device you have, or for like the I2C, I believe, stuff you have. So I put the cables in a rubber band, and I've also put zip ties in a rubber band. So they give you zip ties, and what you can use the zip ties for is to kind of tidy up your robot. So if you have wires coming out of everywhere, it's probably not going to be real neat, and you have a potential hazard, and anything could happen. The wires could get broken if you keep them out. So to prevent that from happening, you want to use zip ties to kind of like tie up everything and keep it all neat. Alright, so now to the electronics. So you have the expansion hub, and so the expansion hub is basically the brain of the robot. It's what connects everything else to each other. And so if you have messed around with FLL or played with Legos before, think of this kind of like as the EV3 brick. So the EV3 brick, you program it right, and you connect all your motors and stuff to it. So you don't necessarily program this, but this is where everything is connected. So like on here, you can even read it. This is where you add your analog inputs, your digital inputs or even outputs, and your I2C stuff. The other side is for your motors, and on the bottom here you have your servos, and then your plus 5 volts. But yeah, this is where everything's connected, and then the battery is also connected up here. But yeah, so everything's connected here, and also your phone connects here when you're programming. And so further into the box, there's some more cables. And so you have like a switch for the battery, I believe, and you have some other stuff, but we'll get to that when we get to electronics. But that's what's in here. There's also some stickers to decorate this thing a little bit. That's what's with the hub. So the hub is a very vital component to the robot and to the kit. Connects everything. Alright, so now we have our motors and our servos. So again, I've gone ahead and taken them out of the bag, and I just took out there was styrofoam in here. I took those out so I could put 2 motors into one box, because it was taking up a lot of spaces and I needed the extra boxes. So we have our motors here, and so these motors are rated for about 100 RPM, and they have a 60-to-1 gear reduction, and they also have a motor encoder. So what that means is that this has a lot of torque. So torque is basically power, so it has a lot of power, so it can lift heavy loads and it can drive a heavy robot, basically. That's what that means. And so with the 60-to-1 gear ratio, it is very powerful. And so with the motor encoder, if you're doing what that is, that allows the motor to read position and kind of get position feedback. And so it's a sensor, and it's on the bottom, and so it's actually a Hall effect sensor, and so it allows it to measure position and rotation and stuff like that. So that's what the motor, the DC motor, does. And you can see there's even the two different cables. So the black and the red, this is just strictly for the motor. And then the other stuff, you can even take it out as well. But this is all just for the Hall effect sensor, the motor encoder part of it. And so that's all in blue. It's at the bottom. So it has a lot of torque, and of course you can always use the gears to change your output speed and mix that up a bit. But it's good to start off with a lot of torque from the motor, from the motor itself. That way you can change it up if you want to. We also have servos in here. I can remember which box it was in. So our servos are in here. And so if you're wondering what the difference between the servo and the motor is, they are very similar, but there's a slight difference in it. So a motor by itself cannot measure its position. So that's why we have to add the motor encoder on there. That's why the company, right, TETRIX, added the motor encoder on it. So if I just had a regular DC motor, it can't measure its position. It only spins. You just plug in the positive and negative end of it to a battery and it spins, right? So you have to add a motor encoder to it to read its position. That's one difference. With the servo, it already has a position measuring device inside it. It has a rotary encoder, which if you think of like a knob on a door, that's what it is. So you can turn a knob on a door. That's what a rotary encoder does. And if it's actually a potentiometer specifically that's inside here, and so that helps measure its position. Another difference is that with a DC motor or any motor that's not a servo, you can spin this freely. So this spins continuously, right? 360 degrees, whatever you want. It just keeps on spinning. With a servo, there is a limitation. So most servos usually can only spin 180 degrees, but some of them vary. Some of them actually do spin 360, but most of the time it's either like 180 or even sometimes 270, but they do have a limitation. So now the question becomes, what do you use each for? So if you're trying to drive your robot and move it forward and backwards, you want to use a DC motor, of course. You want to use a motor because you want continuous rotation. A servo would be used for something that you don't need continuous rotation for necessarily. So think about a robot claw or an arm, right? It's going to open and close like this, right? This doesn't need to spin 360 degrees, right? It just needs to open and close, and this is about like a 90-degree angle, right, that I'm making with my hand. So it's not that much. So you use a servo for this because it is smaller, so it'll take up less space, and it would just be a waste to use a motor for something that doesn't even require full rotation. So use a servo, and the servo is also like I said, it has a potentiometer, so you can read the angle, and it's a little bit more accurate than what the rotary encoder may measure, but that depends on the encoder. So that's what the servo is. The servo also comes with servo mounts. So there already is a servo mount on this, as you can see, but you can take this one off and swap it out with this to mount it with different stuff. So I think as it is, this one can't really mount anything on, but this one can. So you can switch those out. And there's 4 servos and 4 DC motors as well. So these are 2, and then the other 2. Alright. So next we have our servo mounts. So this kit is used to mount the servos, And so there was 4 of them for all the servos, and I just put them all into one box since they're pretty much all the same pieces. So you can even see the 4 different pieces. So these are each for the servo to help mount it onto the robot. And then we also have a charger. So this is for the battery, and I should have opened that one first, but we have a NIM battery, and it's 12 volts. So this is what we're going to use to power the robot. It's going to plug directly into our hub, and this is what we're going to use to power the robot. And then, like we just saw, the charger for the battery. And so that's pretty much what comes with the kit. And so with all of those parts, you can create a lot of different stuff. So I'll move that out the way. And just get everything kind of into frame. So servos, servo mounts, motors, DC motors, metal pieces, our hub, omnidirectional wheels and regular wheels, our battery, and of course all of our pieces that helps us to fasten stuff up and screw things on. All of our smaller pieces and our mounts are on here. So apart from what comes with the kit, you will need some other stuff. So you'll need a controller for the robot, and this is all electronic stuff, no tools or anything. You'll need a controller, 2 phones, and some more connector pieces, but we'll get more into that when we do the electronic part of stuff. But just keep in mind you will need those. And yeah, so that's pretty much it. This is what comes with the kit, and so now we'll go ahead and build the robot in the next video.